Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 68. Today we'll talk about surface area, specifically the surface area of a sphere. The surface area of a sphere could be imagined by looking at tiny shapes on the sphere that are almost flat or nearly flat. So the surface area is the sum of the areas of all the nearly flat polygons. You could make each nearly polygon into a nearly pyramid with a height as the radius of the sphere. Then you could divide the sphere's volume into the nearly pyramids and calculate the area of the base, which would turn out to be the surface area of the sphere. So let me go through those calculations. S is going to be our surface area of the sphere. It's the bases of all of our almost flat polygons. We could add maybe 1,000 of these bases together. The volume of the sphere as 1,000 pyramids would be the volume of a pyramid, 1/3 the area of the base times the height. In this case, it would be the radius of the sphere as the height. So here we have a sphere. We could use whatever polygon shape we want. Maybe we choose a hexagon. So we have lots of 1,000 little hexagons all over this. And if we were to look from the side, here's a little hexagon. We're going to make a pyramid into the center of the sphere. So now we're looking at the volume of each of these 1,000 pyramids that go into the center of the sphere. So that's the volume of the sphere as if it were 1,000 little pyramids. So the pyramid is the area of the base, and then 1/3 and the height. The height, again, is the radius of the sphere. So here is just kind of a little bit condensed. We could take the 1/3 and the r from each of these pyramids and factor it out and put it in front. And then we could say all of these bases are added together. What were all of these bases added together? Well, that was the original surface area of the sphere that we had said. So 1/3 r times the surface area of the sphere is what the volume of the sphere is. And what do we know as the volume for the sphere? In our last lesson, we learned that that was 4/3 pi r cubed. So if we then set that equal to 1/3 r times s, maybe we could get rid of some of these and get s by itself. So if I cancel one of these r's with one of these, we now have r squared left. If I multiply both sides by 3, I get rid of these thirds on both sides. Now I'm left with the surface area of the sphere only on this side, and on the other side I have a 4 pi r squared. So that is then the surface area of a sphere. It's 4 pi r squared. So our formula for the surface area of a sphere with a radius of r is surface area is 4 pi r squared. Let's use this in our first example. Find the surface area of a sphere whose volume is 12,348 pi meters cubed. So we know that the volume of a sphere is 4/3 pi r cubed. And in this case, we know that it's equal to 12,348 pi. With a pi on both sides, I can cancel that out. Then I want to get this 4/3 over here, so I'm going to multiply by 3/4. If I multiply this side by 3/4, that cancels and becomes 1. So we're left with r cubed is 12,348 times 3/4, which is 9,261. So then if I take the cube root of both sides here, I can get r by itself. R will be 21. And what were our units? Well, the volume was meters cubed, so R, our distance, is just going to be meters. Now I'm going to use the formula for surface area, 4 pi r squared. And I'll use 21 meters for my R. (21 squared is 441. 441 times pi is 1764. I'm sorry, 441 times 4 is 1764, and then I still need to multiply by pi. And when I multiply by 3.14, it's about 5,541.8, and this will be meters squared. Right up here I had meters squared. So our surface area is 5,541.8 meters squared. Our last example is a long one. Assume that a Kickapoo wigwam is a semi-cylinder with a half hemisphere on each end. The diameter of the semi-cylinder and each of the half hemispheres is 3.6 meters. The total length is 7.6 meters. What is the volume of the wigwam and the surface area of its roof? So we have half of a hemisphere on this end and half of a hemisphere on this end. That means that we have an entire hemisphere. So when we're trying to find, we'll start with the volume, we have half of a sphere. We have a whole hemisphere, which is half of a sphere. That's our volume for the ends. Now we need the volume for this in the middle. Well, that is half of a cylinder. The cylinder is going to be base times height. The base is going to be a circle, so pi r squared. Our r is going to be half of the diameter of 3.6. It said here that our diameter was 3.6, so half of 3.6 is 1.8. That's our r. So this is again the base of the cylinder, and we only have half of the cylinder since it's laying flat on the ground. So the base of the cylinder times the height of the cylinder, and in this case that is the 4 meters in between. So if we do the math here, you're going to have a pi on both sides. Oh, let me put in my r cubed. So 1/2 times 4/3 is going to be 2/3 pi, and again our r is the 1.8. And then we'll be adding the half a cylinder. All right, so when we do all of that math, you'll find that we're at about 10.37 pi meters cubed. When we multiply by pi, we get that it is approximately 32.58 meters cubed. Now let's look at the surface area. Again, we have the surface area of 2 half hemispheres, or 1 whole hemisphere. The surface area of the hemisphere would be half 4 pi and then r squared. Our r is 1.8 meters squared. And then for the cylinder, that is just the half of a rectangle. So remember that when we open up a cylinder to that lateral side, we're just get a rectangle. And this rectangle is the circumference of the circle base times the height. And the circumference is 2 pi r, or pi d. But then we only have half of it. So if we take half of 2 pi r, it would just be pi r. So pi times our r times our height, which is the 4 meters. So the hemisphere surface area is 6.48 pi, and then the half of the cylinder is going to be 7.2 pi. We add those together for a total surface area of 13.68 pi, and when we multiply that pi, we're going to get 42.98. When we look, that's meters squared.